The AWG series family of instruments can be configured as an arbitrary function generator, a powerful arbitrary waveform generator, a digital pattern and pulse pattern generator. There are 4 different user interfaces that give you access to all the instrument's features. The simple Rider UI allows you to have access to the AWG mode of the instrument. The True-Arb software discloses the AWG mode of the generator. The SPG software lets you to use the pulse pattern generator mode, and finally, the Waveform Editor is an essential tool to create both analog and digital waveforms. During this tutorial, we will take an in-depth view of the True-Arb software and also a quick description of the Waveform Editor tool. The Active Technology Rider Series AWGs share the same easy-to-use interface based on touchscreen and gestures. It is very intuitive and you can control your instrument like a mobile phone or a tablet, drastically cutting the learning curve of the AWG. You can create and generate your first waveform in just few touches. The instrument has a 7-inch capacitive touchscreen display, and it can be controlled easily using your finger and gesture like a mobile phone. Everything that I will do now with the mouse, you can reproduce it with your fingers. The user interface is divided into 3 main areas. On the bottom, you can find the command bar that contains all the buttons to control the arbitrary waveform generator. Pressing this button, you can start and stop the instrument, send a software trigger, turn on and off the analog, the marker and the digital channels, access to the setting of the AWG, to the waveform list, and you can control the instrument by remote. If you press the More button, a new menu will open and you will be able to save and load the project, run the calibration and the diagnostic, add the license keys and launch the Waveform Editor software. That is a powerful tool that lets you to create analog and digital waveforms. The core of the user interface is in the top, where you can find the sequencer. The sequencer contains several entries, you can add up 16,000, and each entry contains the waveforms that will be generated by the arbitrary waveform generator. Here in the middle there are the entry parameters in terms of amplitude, voltage high, low, number of repetition, and length, that is the duration of the waveform, that can be expressed in number of samples or time. Now let's create our first sequence of waveforms. We select a sine waveform in the first entry and we are going to change the amplitude. We will select 2 volt as voltage high and -2 volt as voltage low. Now press the plus button to add another entry, and in the second entry we insert a ramp waveform and we will change the number of repetition to 2. Let's add the last entry. In this case we will select a sync waveform with 3 repetitions. If you press the first entry of the sequencer, the True-Arb software will show you an overview of the programmed entries in the channel 1 and in the channel 2. We press now the Run button to start the generation. Let's take a look now to the oscilloscope screen. As you can see, the AWG 5000 is generating 3 different waveforms. The first one is a sine with the amplitude plus 2 volt and -2 volt, the second one is a ramp repeated 2 times, and the third is a sync repeated 3 times. Now let's take a look to some important features of the sequencer. You can change the amplitude and the duration of the waveforms without creating new ones. For example, we are going to change the amplitude of the ramp waveform from plus and -1 volt to plus and -2 volt. We are changing now the length of the waveform from 16,000 samples to 200,000 samples. In this case, you will see that the software will keep the last point of the current waveform until the end of the waveform. Anyway, there are different strategies that you can adopt when you increase or decrease the number of points of your waveform. If you press the Settings button, in the device settings there are different resampling strategies. If you need to increase the number of points, you can decide to replicate the samples, hold the last point, return to 0, or make an interpolation. If we select now interpolation, you can see here that the waveform has been interpolated and it has now 200,000 samples, and the duration is different. If we select hold last, the last point of the waveform will be repeated until the end of the waveform. There are also strategies to decrease the number of points of your waveform, and you can decide to cut the tail of the waveform, cut the head, or make a decimation. We are going to explore now the settings of the instrument. Press the Settings button on the command bar and you will have access to the device and channel settings. The Run mode defines the sequencer running mode. In continuous mode, the waveform sequence is repeated continuously. In single burst mode, the waveform sequence is repeated once or for a number of times that you can write in the text box below. In triggered continuous, the instrument waits for a trigger before starting the generation. After that the trigger has been detected, the waveforms are repeated continuously. In step mode, the instrument waits for a trigger before generating the waveform contained into the first entry. Then it waits for another trigger before generating the second entry, and then it waits for another trigger before generating the third entry. The advanced mode is a powerful way that allows you to create very complex waveform scenarios. You can make conditional and unconditional jumps, go to instruction, pattern jumps, and so on. Let's take a closer look to that mode. If we return to the main page of the software, you can see that now there is a new icon near the entry parameter. It is called Edit Entry button. By pressing it, you will have access to a graphical editor of the sequencer entries. You can program in an easy way very complex instructions. Entry Editor Graphic Table allows you to set the sequencer instruction in graphical way. For example, in the entry 1 we are going to program the wait event extraction. The instrument waits that the event will occur before starting the generation. The event can be button, that means a software trigger, an internal timer, or an event that comes from the triggering connector. Let's program a software trigger. Wait event button. After that the event has occurred, we have to decide how many times we need to repeat the waveform. The second instruction is a jump if event. The instrument will jump to the selected entry in the jump to selection box. The jump if event can be button, timer, or external. This time we select timer. You can set the value of the timer in the settings of the instrument. The Jump to Selection box allows us to go to the next, previous, first or last entry. If you select Item, you can type the number of the entries that will be the destination of the jump. The Pattern Jump instruction allows you to perform dynamic jumps. On the rear of the instrument, there is a D-sub connector with 8 pins that can be connected to digital signals. When the sampled value will be equal to the value that you write here, the instrument will jump to the entry selected in the Pattern 2 entry box. The last instruction is an unconditional jump called Go to Entry. Next, previous, first, last or item number can be the destination of the unconditional jump. Now we will program the other two entries and we will run the sequencer in advanced mode. Now let's take a look to the settings of the instrument. Pressing the settings button, you will have access to a page where you can set the device, channel, marker and sequencer set parameters. We've already analyzed the general settings of the device section. Now we'll pass through the timing section. This section allows you to change the sampling rate. The sampling rate and the total number of points of a waveform are strictly related to the frequency of the signals that will be generated. In the clock source section, you can decide to select the internal clock, or you can synchronize the AWG with an oscillator that comes from the outside. Now we are going to change the sampling clock from 6.16 GHz to 1 GHz. And as you can see from the oscilloscope, all the frequency of the waveform have been decreased. The amplitude scale, the skew and the baseline offset are three runtime parameters of the analog channels. If you run the instrument, you can see that changing the value of the amplitude scale, it will vary the amplitude of all waveforms of the selected channels. The skew allows you to change the skew between the analog channels with a resolution of 100 femtosecond. The baseline offset changes the hardware offset of the selected channel. Using this parameter, you can obtain 10 V peak-to-peak voltage window. With the polarity, you can invert the polarity of the signal, and you can, for example, create differential signals using two single-ended outputs. Let's make a practical example. The digital tab is necessary to set the parameters of the digital channel. For example, you can enable the number of the available channels, and you can set the voltage level from 0.8 volt to 3.8 volt. In this case, let's set 2 volt. You can set also the skew between the analog and the digital channels. As you can see now, we can enable the digital lines pressing the digital button in the command bar, and after that you can insert the digital waveform in the selected entry.